let's create a BIOS firewall. So if we pop into Data Store 2 and we go to the Data Store browser, we should have the ISOs folder, right? And in those in that ISO folder, you should have the BIOS VM and Xubuntu as well. So what we're going to do is we're going to use this as an installer data source to build our 480 firewall. Let's do it. All right, so we'll go to virtual machines. We'll create or register a virtual machine. We'll go to next. Let's call this 480-firewall. We're going to make it an ESXi 67 U2 machine. Actually, I lie. We're going to make it an ESXi 7 machine. So the reason why we do this is if we have a large ESXi infrastructure, we'll likely have a mix of 7s, 8s, maybe even 6s. You're going to want to pick the least common denominator. That way, VMs can move from host to host without having hardware compatibility problems. So for BIOS, it's a Debian system. Debian 10, we'll pick 64-bit. I'm going to store it on Data Store 2, just because I don't necessarily like storing stuff unless I have to on the same hard drive that ESXi is installed on. All right, we're going to tweak the characteristics just a little bit. We're also going to add a new network adapter, so we'll start with that. Boom. So I did that. There's nothing shows up when you do it. Just click it once. We're going to trim down the memory in the hard drive space. Additionally, on the hard drive, you're going to want to make sure that it's thin provisioned. What that means is that your even though it says 8 gigs, it's only going to take what it needs up to 8 gigs. If you say thick provision, it's going to grab all that at once. This is a huge problem when you're doing like a Windows box that really wants 60 gigs. It'll just chop 60 gigs off your data store, which is not necessarily cool because it might only need 30. All right, let's move along a little bit further. So both of these are on 40 WAN. For purposes of building a base VM, right? So when we build these operating systems, we want to really avoid having to do it twice, right? One for our production firewall and one for a base BIOS image. So we build the base first, right? And then later when we have vCenter, we'll extract that base image out as a reusable component. So we're going to keep it generic, and VM network is a good thing to pick. For CDs, we'll pick data store ISO file because we put it there, right? So we can go pick the BIOS ISO out of there. We're going to want to make sure that at boot it powers on. It looks like that might be the default, and that should do it. Okay, I'm going to spin this box. I'm going to pause my video. I spin the box up because it takes a little while for it to come up. Let's open it up in a new tab. All right, let me pause. Okay, so we're now at the point where we can install BIOS. So we have to log in. Default password to BIOS, and the password, username and password to BIOS. So the way we do this, we just type install image, and we'll say yes. Picking the defaults, right? Pause while this does its thing. Oh, I went too fast. So yeah, we'll pick this image. See if there's anything else I have to answer. I'll just go ahead and type it all in. All right, so you're going to want to not use your super duper secret password at this point. You're going to want to use a generic password like Champlain 22. Later, when we create when we create link clones or full clones off the base image, we will use production passwords. Let me type really slowly. All right, I did it. Okay, so I think restart. So you could grab just power off and grab a snapshot, but we're gonna. I want to show you a few things. So let's go ahead and restart. Allied reboot. Yeah. So when you have first boot with iOS, it's going to actually put the hardware IDs or the MAC addresses in the configuration. This presents a huge problem, particularly if you're going to clone it, because then you have duplicate layer 2 addresses, which causes hard to debug networking issues. So we're gonna take a look at that. I'll show you the problem. We're gonna fix the problem, and then we may tweak the configuration just a little bit before we shut down and grab a snapshot. Okay, we're in. So iOS. Okay, now we're going to go to configure. So this is analogous to Cisco's conf t command. So let's type show interfaces. Okay, so you can see that we have hardware IDs in there. They got to go. They got to go. So delete interfaces, Ethernet, ETH0, hardware ID. Same thing with ETH1. And then I'll commit that. Commit, very Cisco-esque, right? Save that and show interfaces. The other thing we're going to want to do is we want ETH0 to kind of pick up a DHCP address automatically. It allows us to immediately go to the box if we want to. So set interfaces, Ethernet, ETH0 address, DHCP. We also, let's take a look at SSH, show service. Looks like SSH has not been set yet. So we'll do a set service SSH listen address 0.0.0.0. So this is going to make sure that SSH is listening. So what we can do is we can observe our new iOS clone pop up. We can figure out what the IP address is, and we can SSH right into it for automation. So we'll commit that. Commit. Oh, I spelled commit wrong. Yeah, too many N's. Commit. Save. Okay, so it's actually been written down. So we can we'll do an exit. I want to power off. Power it off. Yes. Okay, once it's powered off, well, there's a couple things we need to do. we need to remove the CD-ROM. Otherwise, when we clone it, we're going to clone that image of the CD-ROM, which is super annoying, right? And then we're going to want to grab the base image. Yeah. Sometimes it's actually off. Yeah, it appears to be off. So and this little circle means that it's off. So I'm going to do I'm going to go ahead and edit the settings. And this is what I was talking about with the CD-ROM. So it says data store ISO. We just turn it to host device and you'll be fine. So we'll save that off. And then we'll do a snapshot now. So where's my snapshots? Hopefully I didn't take away that capability. So actions. Bear with me while I hunt down the snapshot capability. I'm going to pause my video while I find out where they moved that to. Okay, they didn't move it. I guess my VM just wasn't ready. So right click, snapshots. Take a snapshot, and we'll call it base. Be consistent on what you name this. It doesn't have to be base, but that's just the naming convention that I use on cyber.local. And I actually use that in code, right? So take the snapshot. Oh, by the way, you can take a snapshot of the virtual machine's memory, and if not, you can choose to dump it as well. You can also tell the host to kind of calm down and sync all its data to disk before you take that snapshot. I would not capture memory, right? You take particularly if you have a high memory intensive VM like vCenter. So we'll take the snapshot. Okay, it looks like it was successfully created. Now we can go production mode, right? Because we're going to continue on with this 4D firewall, but we can always go back, right, and extract that base snapshot as its own independent VM. And that's one of the things we're going to do. So let's power back on. A couple things I'm going to do. I'm going to go into edit settings while it's powering on. This is fine. And change that second network to 480 WAN. So we could SSH to this thing if we wanted to, once it's up. Because it's going to pull an IP address on that ETH1 interface or ETH0 interface. Let's see if it does. Should get a Joyce IP address. All right, so let's log in by OS. Name, password. Okay, yeah, take a look at that. It got a 159 address, right? So it's configured DHCP. So one thing you do, you could SSH into that thing right now and use copy paste. That would be helpful, or you can just configure it at the console. The first thing I want to show you how to do is change the password. I'm not going to do it in front of you. I'll do it offline, but you would do it something like this. You would do a configure. Let's go in there. Configure. So set system login user BIOS authentication plain text password, and then super duper password goes here, right? That would be the password, right? And there's other ways to use SSH keys if you want to, but I'm going to do that on my own later. But I'm going to continue on with getting this box up and configured. So the first thing you're going to want to do is you're going to want to figure out your your IP address for your 480 firewall, and mine is 3.41. Or excuse me, 7.41. I have to fix that. Yeah, the IPs are in the 7 range, so I'll fix that. So I'm in configure, so I'm gonna do delete interfaces Ethernet ETH0 address DHCP. So we got to take out DHCP, right? And now we're going to go in and set it. So set interfaces Ethernet ETH0 address. Now, when you type in the address, you also give it the subnet mask. So 192.168.7.41 for me, and it's a /24. I'll commit that. Let's ping the gateway. Ping 192.168.7.250. Okay, that's our gateway. And what we're going to want to do is we're going to want to set our default gateway for hosts that are deep into our network so they can communicate outwards. So this is the way you do it. You set protocols, static route, 0.0.0.0/0. So that's basically anything, the default, right? All IPs fall in that range, right? The next hop is going to be 192.168.7.250. So this is the IP address of the classroom gateway, which we don't necessarily have control over. The other thing that's a good practice is to set description on the interfaces. So set interface ETH0, Ethernet ETH0 description, CyberLab, right? And then set interfaces Ethernet ETH1 description 480 WAN, right? And then we need to set the interface IP address for ETH1. Set interfaces Ethernet ETH1 address. I traditionally use this one, 10.0.17.2.24 for that kind of classroom WAN. So that's what we'll do. Let's see. We're gonna want to. So we got the description. We have the route to the physical gateway. We need to configure our name servers. So the name servers we're going to use are the cyber.local ones. Although you could use I don't know 1.1.1.1 if you wanted to. So let's do this. So set service. Set system. Set system name servers. Let's see. We'll do 192.168.4.4. We'll run the same thing with a 4.5. So these are two of our domain controllers. You could add the third one if you really wanted to, and they will forward requests out as well. So we've done that. Now we need to deal with DNS forwarding for networks that are underneath our 480 WAN or even deeper. So set service DNS forwarding listen address. So we want to listen for requests for domain resolution on 10.0.17.2. And then we want to allow from 10.0.17.0/24. And then we want to forward to our name servers, right? Okay, so now what we want to do is we want to create a NAT rule. A NAT rule, what essentially what it'll do is it'll see that 10.0.17 address, and it will masquerade as the router itself, the router IP. So it's basically going in there and changing the IP headers for you. And this is how most local area networks work when it goes out to the WAN. It's typically NATed in some way or another. So we're just going to use classic NATing. So set NAT source rule. I increment my rules by 10. That's just the way I do it. Um, Source address, anything coming from the 10 dot network, 10.0.17.0/24. Let's see. The outbound interface is the ETH0, the one that connects to cyber. And then we want to masquerade. Last but not least, I'm going to set the host name. Set system host name 40. Firewall 40, or we'll call it 480-firewall. All right, commit that baby. Save that off. Let's just ping google.com, make sure it works. Oh yeah. Okay, so the next thing we're going to do is we're going to actually drop an Ubuntu system. First, it's going to be on VM network, right? And then we're going to connect it to the same LAN that ETH1 here is connected to 480 WAN, and we're going to route right out to the internet, right? Like a real local area network. But that is our next video. All right. So you should be at this point now. So let me stop this video and spin up another one. Boy, that was a long video. I apologize. 22 minutes. Play it at double speed.